Okay, hi everyone. My name is Nur Fatis Mahani binti Ahmad Idris, and I will presenting about TinyOS. Okay, first, what is TinyOS? TinyOS is an open-source, event-driven operating system developed for resource-constrained devices like low-power microcontrollers and wireless sensor networks. It began as part of the Smart Dust project, which attempted to produce tiny wireless sensors capable of sensing environmental changes. TinyOS has now become a popular alternative for a variety of embedded systems and Internet of Things applications. Goals of TinyOS. The primary goals of TinyOS are to establish an efficient, modular, and adaptable platform for creating applications on limited resource devices. The operating system is written in C language, which is a dialect of C language that designs exclusively for TinyOS to provide better support for its unique features and requirements. Because of its effectiveness and lightweight architecture, TinyOS is a widely used operating system in wireless sensor networks. Example of TinyOS. First example is health monitoring system. This system function is to collect vital indicators such as heart rate, blood pressure, temperature, oxygen saturation, and respiration rate using different sensors. For example, ECG, SpO2, and temperature sensors. This system also monitors activity levels through the use of accelerometers and gyroscopes to track steps, calorie burns, distance travel, sleep pattern, and heart rate. Okay. Data analysis and its algorithms are used to identify possible abnormalities such as arrhythmias, sleep apnea, respiratory disorders, and other diseases. These systems can make a user to send a notifications to healthcare professionals or emergency service in the case of an emergency. This is an example of diagram for health monitoring system. The sensor on the system will be sense a disease such as on the picture, on the diagram, which is a blood pressure, respiration rate, body temperature, oxygen saturation, heart rate, and ECG, and will be informed to the device, to our device or IoT device using a gateway AM. Then will be processed into the cloud, and all the data will be stored at cloud, and user can get all the data, all the record on the cloud. Okay, for enhancement, we can combining the data from several sensors to provide more precise and draw help insights. These machine learning algorithms can be improved anomaly detection, identify health hazards, and customize suggestions by user. For non-contact vital sign measurement, the sensors that can be used and applied to the system is likely for more accurate, such as radar or ultrasound. And for safe and quick access to health data, biometric authentication will be used, such as fingerprint or iris recognition. We can implement a strong safeguards to protect sensitive health data of the user from unauthorized access and breaches. The next example of TinyOS application is smart farming system. The function of this system is to supply sensor nodes that gather all the data on soil moisture, temperature, humidity, light level, and nutrient content. This system also can adjust the irrigation automatically depending on real-time soil moisture and plant requirements. This system also includes managing fertilizer applications that depends on soil nutrient levels and plant development. Smart farming system can provide farmers with insights into their fields and crop health through data analysis and visualizations. And this is the example of diagram for smart farming system that using TinyOS. The system will be used IP network that will streaming the video, real time streaming to the user, that using a router and 6 LoWPAN as a bridge for user to see their farm. TinyOS as an IoT device will be used for Internet IP that can be accessed into the system. Okay. The next one is enhancements of the smart farming system. Integration with farming machinery, which is manage drones, tractors, and other machinery for automated planting, weeding, and harvesting operations will be implemented into this system for better use. The cameras and drones could be used to observe plant health and locate a pest like a CCTV. The machine learning techniques can be implemented to forecast yields from farming, disease outbreaks, and can settle the future concerns. The sensor nodes or gateways are applied to process data locally for quicker reaction times and less pressure on the network. Energy-efficient protocols will be used, such as LoRaWAN for long-range data transfer with little battery depletion. Okay, that's all from me, and that's all about the TinyOS that I presented. So, thank you and see you again. Bye.